Right. So today we are going to start third unit. Right. Alt F3. No, and go to the file menu. Press on new. Maximize it, and go to the file menu again. Save. Save with the topic name preprocess.c. See, today we are going to start unit 3. Unit 3. Two topics are there. The first one is preprocessor topic. Second one is file handling. File handling. File handling. Preprocessor is a direct question. And from file handling, we are going to get almost 6 to 7 important programs. Totally, that 1 plus 7, if you read 8 programs, I will guarantee you 4 questions from this third unit in the final examinations. If you go through the 8 important questions, and you will see at least 4 important questions in the final examination. If you read 8, you will get 4. So I will give the guarantee. So first we start with the preprocessor. The first topic in the third unit is a preprocessor. Before that, we will have the idea about how a program is compiled. How a program is compiled. So first we are going to write a source programming code. That means till now whatever the whatever the programs we written till now are comes under source code. Source code contains what? A English programming code. Till now all the programs we created with the .c extension are the example for a source code. So we will write the source code. That means a computer code or a C language code written in the English language. A source code, a source code written in the English language is compiled by the compiler, and that compiler will give you the object code. Or finally you are going to get a executable code. A source code is converted into executable code. When you run this executable code, you will get the output. So what we have to do first? A source code we have to write. A simple C language code we have to write. For example, in the first program we written hello world 2.0, like that we written. That printf statements and that initial code to print the hello world on the monitor, that programming code written in the English language and saved with the .c extension, hello.c. That is the example of source code. So that source code is written in the English language. We must convert into the executable code or the machine code, or we can say machine code, because that English is understandable by the human being. That source code which is written in the English language is understandable by the human, but that human code cannot be understandable by the machine, that means computer. So we must convert that source code which is written in the English language. That code must be transformed or translated into machine code which contains zeros and ones, so that the computer will understand that machine code and when you run that machine code, you will get the required output. But who is translating from source code, English code, to the machine binary code? A compiler. So compiler. And in the first unit, we discussed what is compiler and how many units are there in the compiler. You don't say only compiler is simply converting the source code into the machine code. There are three phases. The first one in the compiler is preprocessor. Preprocessor. Preprocessor in the compilation section. Then compiler will take care about the remaining code. After compilation, we have a assembler. So don't think about assembler. That is sufficient. If you write processor and processor, what is that? A preprocessor. It is preprocessor. So preprocessor is the first module in the compiler. Then compiler will take care. Then after compiler, we have a assembler. We have a assembler. Then from this, a linker will link required modules. Then that program is converted into machine code. You see, first source code we have to write. That source code is given to the input to the compiler. Compiler is having three modules. First one is a preprocessor. Second one is a compiler and assembler. Then we have a linker. After that, that linker will produce the machine code. That machine code we will run by using the, what we can say, runner. Then we will get the output. So source code first given as an input to the preprocessor. Preprocessor, already we discussed in the first unit. Preprocessor will do three things. First one is removing all the single line and multi-line comments is the first responsibility. Then replacing all the macros with its original values is the second responsibility. And what is the third one we discussed under preprocessor? Substituting all the what we can say libraries that we include under std, I mean hash include section, replacing all the header files with its original code. So these are the important three things done by the preprocessor. Then after compiling, I mean after doing the pre-processing, that file is given to the compiler. Then compiler will convert into the a object code, I mean assembly code. So assembly code again need to be converted into object code. For that assembler is used. Compiler will take the file from preprocessor. That file is English code is converted into assembly code. Again, assembly code contains mnemonics, so that mnemonics cannot be understandable by the machine directly. So that mnemonics or assembly code must be translated into the byte code or object code. So again, we are using assembler. So assembler will translate that what we can say that assembly code into the object code. Object code contains zeros and ones. So for that object code, a linker will add additional required modules. After that, it will produce directly a machine code, which is understandable by the computer. So this machine code is run by the runner. That runner, when it runs the machine code, we will get the required output. We will get the required output. So now we are going to discuss about this section, preprocessor section. How a preprocessor will process. How it knows it has to process some part of the program. So that we are going to discuss. So we start with what is preprocessor. What is preprocessor? So as I said, a source code is pre-processed by this preprocessor before compilation. That means before compiling a source code, a preprocessor will process the source code first. Then after preprocessor is processed this source code, that file is given to the compiler. Then from the compiler, assembler will take it. From the assembler, a linker will take it. From the linker, machine code will take and it will produce the output. So we are talking about preprocessor section. So same thing I am going to write. A source code is processed by the program before compilation before compilation before compilation. That program is called preprocessor, comma, and this process is called pre-processing. Just to read the definition, a source code is processed by a program before compilation. Before compilation, what is happening? Some processing is going on by the program. That program we are calling as a preprocessor. What is that program name? That program is called a preprocessor. And the process done by that preprocessor program is called pre-processing. What we can say? What is pre-processing? The process done by the preprocessor program is called pre-processing. Let me read one more time. A source code. What is the source code? A code written in the English language is processed by the program before compilation. Before this compilation, a program will process the source code. That program is called what? That program is called preprocessor, and that process done by this preprocessor is called and this process is called pre-processing. So that is the definition of the preprocessor. The commands used in here we will write the commands used in this pre-processing are called are called pre-processing directives. The commands used in this pre-processing are called pre-processing directives, or we can write a pre-processor 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 directives also. The examples are some examples of pre-processor directives are that pre-processor directives examples are given below. The first one, and directive name, and the example. That we are going to write here. The first one is macro. Already we discussed in the first unit. We defined pi macro by using the hash define instead of example we can write directive here, And here you can write type of macro. You can write type of macro. You can write here. The directive is the command represented with hash define. This preprocessor directive define hash define is used to define a macro. Already we discussed about pi macro in the first unit, how to define the pi value 3.14. That means defining a symbolic constant we already seen. Not a problem, we will going to discuss it one more time. But how can you say this is a pre-processive directive, or how can we say, and how can we confirm this is a preprocessor directive or preprocessor command? Means all the preprocessor directives or commands are denoted with that hash symbol. When you see the hash symbol before a command, then we can confirm that command is a preprocessor command or preprocessor directives. Same thing we will write here also. Same thing we will write here also. All the preprocessor directives are preprocessor directives will start with hash symbol. Start with hash symbol. So here is also hash define is a preprocessor directive used to define a macro or a symbolic constant. Second one, file inclusion. File inclusion. File inclusion. For file inclusion, that means including any header file. So in all the programs we included hash include stdio.h and conio.h. That means in every program we are including stdio.h header file and conio.h header file. To include those header files, we used hash include command. So same thing we are writing hash include. This preprocessor directive command is used to include the file. That means file inclusion preprocessor directive. The third type is conditional compilation. Conditional compilation. The conditional compilation commands are hash if def, comma, hash endif, comma, hash if, comma, hash else. So all these are we are going to discuss, and the last one is hash if and def. If and def. So these are the commands if def, end if, and if else, and if and def. All these are preprocessor directives discussed under the category of conditional compilation. Conditional compilation. That means this preprocessor directives will allow to include some portion of the statements into the program before compilation when condition is satisfied. That means if the condition is satisfied only, we are going to add some commands into the program before compilation with the help of these preprocessor directives. And the last one, the fourth type is the other preprocessor directives. Here we are going to discuss hash undef we are going to discussing. Then we have a pragma. No need to discuss about pragma, and it is not working in the turbo C also. Just remember there is a preprocessor directive pragma also. Up to undef we are going to discuss, and I am going to give the idea about pragma. So let me discuss the first type. The first one I am going to discuss macro. Under this only I will discuss macro and file inclusion. That means I am going to discuss in the first point hash define and hash include directives. These two directives I am going to discuss. The first one, hash include. Hash include, what is the meaning of this directive? Hash include directive, hash include. This preprocessor command or this directive is used to include a file in the source code before compilation. If you want to include any file, then we are going to use hash include. And that source code, what we can say, this directive is used to include a file in the source code before, or we can write the directive is used to include a file in the source code. Which file we are talking about? We are talking about the header files. Header file is included into the source code before compilation, and that code is included in the place of place of in the place of the file name. That means the hash include syntax is hash include angular braces. In between we have to write a file name. Which file you are going to include into your source code, that file name you have to write. So that this directive is used to include the file. The file, what is the file? The file name you given inside the angular braces. That file is included in the source code before compilation in the place of where you written that hash include. So this is the directive is used to include a file in the source code before compilation in the place of the file name where you written that. Excuse me. Right. So this is all about hash include. Next one is what? The next one is hash define. Hash define. This directive is used to define a symbolic constant or used to create a macro, or we can write a symbolic constant. Symbolic constants are macros or macro. That is the meaning of hash define. Hash define is used to create the macros or symbolic what we can say constants. For this we will see one example program this particular hash include and the hash define section. So first I'm writing hash include. Already we used hash include in so many programs. Hash include, I want to include stdio.h. How to write? The file name is stdio.h, so that the stdio.h header file is included exactly in this place where you written hash include. So in that place, the code inside stdio.h header file, already code will be written and it is inside the stdio.h. That header file code is replaced exactly in this place before compilation, not after compilation. It is useless if you add the stdio.h code inside the source code after compilation. It is not required. So before compilation only we have to add, then that code is compiled along with our source code and we are going to get the exact required output. Next I'm going to add the second file also, second header file also, which is required in our program, because stdio.h we need printf and scanf. In hash include conio.h I'm going to include. In that we have two important functions code, that is getch and clrscr. So conio.h. So how to include conio.h header file? Again use the preprocessor directive hash include. This directive will indicate to the compiler to add conio.h header file before compilation. So whatever you written, whatever you write with hash define, I mean hash symbols, all those hash symbol written commands are called preprocessor commands or preprocessor directives. Those preprocessor commands are processed by the preprocessor. Whatever you are writing with hash symbol, all those symbols are processed with the preprocessor and remaining are directly compiled with the compiler. So what do you understand? The commands written with hash symbols are called preprocessor directives, and those commands are processed by the preprocessor before compilation phase. So in order to what we can say, if you want to execute anything or if you want to process anything before a compilation, we must use that preprocessor directives, which are starting with the hash symbol. Hash symbol means the preprocessor commands are directives. So now I am using the hash include and stdio.h. This file is included here, and conio.h. This file is included here by using the preprocessor command hash include. And what about next one? Hash define. Hash define is a what we can say, it is used to create symbolic constant or macros. So I am writing pi, where pi is a macro, and that macro I am storing with the value 3.14. What is the actually meaning of the macro? If you search in the Google, macro means which records something. That means I called pi is a macro. That means it records the 3.14 value, or we can say 3.14 is stored into pi when you define the pi value by using the hash define directive. Now I can confirm that the hash define preprocessor directive is used to define the macro pi with the value 3.14, and this pi is or this macro is created or processed before the compilation process by the preprocessor. Now I am also defining another value, hash define. So first we will write pi, and then I'm writing void main. Then I'm writing void main. Here I am writing one clr scr and one routine command getch also I am writing. And to make it run, I am commenting all other non-C programming code with the multi-line, and go to the starting and put it in the multi-line comments, and don't uncomment the program. I mean, only uncomment the program, and remaining you comment. Right. So here, when you compile it, what will happen? Before compilation, stdio.h and conio.h, both the files are included. When you do, we written source code. We written source code, and that source code name is preprocessor.c. That preprocessor contains which code? This is the code it contains. This is the code it contains. So when you try to compile, first compiler will not take care about the code. First, the first module in the compiler, preprocessor, will take the source code preprocessor.c. So after that preprocessor.c is given as input to the preprocessor, what it will do? It will first it will remove all the multi-line and single line comments. Then it will substitute all the required header files by using the hash include directive, and after that it will replace all the macros with its original values. So first, this all multi-line comment is removed by the preprocessor. Second one, whatever we written hash include stdio.h, those stdio.h and conio.h is replaced in these two lines. The code inside stdio.h and conio.h is replaced with these two lines. Then if you use the pi inside the program, for example, here I am writing some pi value, I'm printing some value, printf. Here two new lines you can take. I want to print pi value, pi equal to percentile f, comma, you write here pi. Now when you try to compile it, this pi value is replaced with 3.14. That is the third responsibility of the preprocessor. First one is what? This is totally a source code and saved with preprocessor.c, and next to run it we will compile first. So when you are compiling this program preprocessor.c, which is a source code, first compiler won't take care about it, it won't take the source code. The first module in the compiler will take care about the source code. So what are the responsibilities of the preprocessor? The first one is removing all the single and multi-line comments which are unwanted in the program. So this multi-line multi-line comments are removed. Then what is the second responsibility of the preprocessor? Second responsibility is substituting all the required files written with the hash include section. What are the required files? stdio.h header file and conio.h header file. These two files are replaced with actual code of stdio.h and conio.h. And third responsibility is the macros. If the program contains any macros, here pi is the macro, all the macros are replaced with its original value. So that pi is replaced with 3.14 wherever used. So where you are using it, here you are using the pi is replaced with 3.14, and that 3.14 is replaced in the place of percentile f. And what is going to be printed?